Hey guys, this is Elaine, and in this video I'm going to talk about interactions of photons with matter. Let's start by the classification of radiation. Radiation is classified as being either non-ionizing or ionizing. Non-ionizing, it does not have enough energy to remove an orbital electron. Ionizing, it has enough energy to remove an orbital electron, causing it to become ionized. In cancer treatment, we use ionizing radiation, which consists of subatomic particles or high-energy electromagnetic waves. Examples of particles are electrons, alpha particles. Electromagnetic waves are gamma rays, X-rays. Gamma rays and X-rays are photons. In the video Radioactivity Part 1, I explain about gamma rays. If you have not watched it, the link is in the description of this video. So let's remember some of the basic properties of photon. They have no mass, no charge, they carry energy and momentum, which are dependent on the frequency. They can have interactions with other particles. Attenuation is exponential with the thickness of the absorbing medium. So a beam of photons that cross a medium only attenuate in intensity. When an X-ray or a gamma ray beam passes through a medium, interaction between photons and matter can take place. That means photon interactions with matter are probabilistic. There's a chance of happening that can be a high chance, a low chance, if certain conditions are met or not. Interaction between photons and matter can take place with the result that energy is transferred to the medium. The initial step in the energy transfer involves the ejection of electrons from the atoms of the absorbing medium. When photons interact, they transfer energy to particles, usually electrons, and the charged particles give up their energy via secondary emissions. As far as absorbing medium, if we are talking about tissues, body tissues here, sufficient energy may be deposited within the cells during this interaction, destroying their reproductive capacity. Three most common forms of interactions are the photoelectric effect, Compton scattering, and pair production. Photoelectric effect, photon interacts with an orbital electron. Let's take a look at this picture here on the right side. We have incident photon coming, interacting with an orbital electron. In the process, the incident photon is completely absorbed by the atom. It disappears, and the orbital electron is ejected. This orbital electron can be from K, L, M, N shells, but usually from the K shell. The probability of occur is for energy is lower than 100 kiloelectronvolts. Photoelectric effect has a strong dependence on the incident photon energy. That's the relationship, which is 1 over e to the third power. That means as energy increases, the probability of photoelectric effect occur decreases very fast. Compton scattering, the incident photon interacts with an orbital electron as it were a free electron. Why do we say free? In this case, it's because the binding energy of the electron is much less than the energy of the incident photon. Usually, this electron is from the outermost shell. So we have here, let's take a look in this picture here on the right side. We have an incident photon coming, interacting with a free electron. The incident photon is deviated from its initial trajectory. and it's called scattered photon. The electron is ejected. The probability of Compton scattering occur will be between energies 25 kiloelectronvolts and 25 megaelectronvolts. Probability higher in the megaelectronvolts range. Compton scattering has a slight dependence on incident photon energy. Pair production. So as far as pair production, there is a big condition here, which is the energy of the incident photon has to be greater than 1.02 megaelectronvolts. There is a threshold. Energy is lower than that, this effect will not occur. This kind of interaction, pair production, will not occur. So when the incident photon comes, interacts with the electric field of the nucleus. Here is also one of the differences between pair production and the other two previous effects that I talked about. In pair production, the incident photon interacts with the electric field of the nucleus. As far as the first two, the incident photon interacts with electrons. So let's take a look at this picture here. Incident photon comes, interacts with the electric field of the nucleus. It's completely absorbed in the process. There is a production of a pair, a creation of a pair, emission of a pair here, which is an electron-positron pair. So pair production is the creation of an elementary particle and its antiparticle. Here we see energy directly converted to matter. The probability of occur increases for energy greater than 25 megaelectronvolts. For pair production interactions depend on the incident photon energy. So there is a dependence there. As energy increases, the chances of pair production to happen also increases. Let's take a look in this graph here. We have photon energy in megaelectronvolts in the x-axis, water linear attenuation coefficient in the y-axis. And let's take a look at this curve here, which is the first one, which represents photoelectric effect. We can see that as energy increases, the chances of photoelectric effect occur decreases. And it's a very strong dependence on energy. We clearly see that. As far as Compton scattering, as the energy increases, the probability of Compton scattering occur decreases. Less is more of a weak dependence. As far as pair production, as the energy increases, the probability of pair production occur increases as well. And we can clearly see here the threshold below that energy, which is 1.02 megaelectronvolts. There will be no pair production effect. So I'm going to stop right here just to make this video short. It is meant to be an introduction. There are 3 additional videos where I explain these photon interactions in more detail. Here I only talked about the energy dependence that they have, but there are other factors that they depend on, and which I'm going to explain better in the next videos. So this is it, guys. Thanks for watching.